Hello learners, in this session we are going to learn about sedimentary basins of India. So, here we will first introduce this, what is a basin, we will define the basin and then see the various types. Then we will learn about the characteristics of sedimentary basins. Then the major sedimentary basins of India that we will learn about. Then the importance of the sedimentary basins, then the challenges and the prospects, and then finally we will summarize what we have learned in this session. So, let us start. If you see a rock, here we are taking example of a sandstone. So, as you can see in this figure, there are various sand particles, and here you can see you can also see quartz grain. So, each quartz grain in the sand or a sandstone has a distinct story to tell. What is this story about? That the quartz grain that is there in the sandstone, that originally might have been a crystal in an igneous rock like granite or granodiorite, or it could be metamorphic rock like quartzite or gneiss, or a sedimentary rock like sandstone. So, this quartz crystal along with other grains and minerals got detached, released, and then liberated from the parent rock by the process of weathering. Then this become a loose quartz grain, which may then be deposited either in situ, or it may be transported to some place by some media, and it may participate in the dynamic surface process, and eventually that grain got deposited in the ocean basin along with other grains to form a layer of sediment. These loose grains are further compacted, bound, or cemented to form the sedimentary rock, like as you see here in this photograph, sandstone. So, we have seen about the story of a single quartz grain, and that is one particle we can say here. The particles that form a sedimentary rock may be composed of detritus minerals or biological detritus or organic matter, and this is called sediment. And these sedimentary particles or sediments are the building blocks of sedimentary rocks, and we know that sedimentary particles may be heterogeneous or may be chemical precipitates or even organic materials. So, we talked about a single grain, how it was detached from a rock, parent rock, and how it finally got deposited in a basin. So, deposition of sediments takes place when energy necessary to transport particles is no longer available. If the velocity of the transporting medium becomes too low, the deposition takes place. The sediments fall down due to the gentle settling of mineral grains and deposited in a basin as layers, with the oldest layers at the bottom and the younger layers lying over the older layers. This is a figure that a block diagram that shows the entire process right from weathering and erosion to its transportation and deposition, and then finally its lithification and transformation into a sedimentary rock. So, the process of transformation of sediment into sedimentary rocks are lithification and diagenesis, by which loose sedimentary particles deposited in a basin are transformed into a rock. So, here we use the term basin. Now, let us understand what the basin means. Basin could mean different to different people from different backgrounds, but here in general we can define basin as a geographical area where all water drains toward a common outlet. It can refer to various types of natural formations depending upon the context from which we are looking at. So, to a geologist it is a large scale natural depression in the earth's crust where sediments accumulate over time. For example, here example is given here, the Katappa basin. Then to a geomorphologist, it could be it is defined as a topographic depression or low lying area, often enclosed by mountains or hills, and there are some examples here given. In the field of hydrology, it is an area where all precipitation drains into a common outlet. In the context of petroleum exploration, it is a geological depression where thick sediment layers accumulate, which often contain hydrocarbons. To a structural geologist, it could be a bowl shaped fold in rock layers with younger rocks in the center and older rocks at the edges. And to the oceanographer, it is a large depression in the seafloor formed by tectonic or volcanic activity. From an economic geology perspective, it is a geological region with high concentrations of mineral deposits like coal, oil or metals. And from the perspective of agriculture and the environmental science, it is a land area designed to collect, store and distribute water for irrigation and farming. So, we saw that what is a basin, but the basin could have different meanings for the people from different backgrounds. However, the common thing is that a basin is a depression or low lying area that accumulates sediments, water or the other materials over time. Understanding of a basin helps us as a geologist or hydrologist or to environmental scientists analyze Earth's processes and resources effectively. Here the topic of our interest is the sedimentary basin. So, what is sedimentary basin? It is a low lying subsiding area on the Earth's crust where sediments accumulate over millions of years, and these basins are key to understanding Earth's geological history, natural resources and plate tectonics. They are important for exploration of oil, natural gas, coal, groundwater and mineral deposits. We can classify sedimentary basins based on various characteristics, and this classification helps us in understanding the formation, evolution and resource potential of these basins. The main criteria on the basis of which the classification is done, that include geographical location, depositional environment, tectonic setting, hydrocarbon potential and also subsidence mechanism. So, let us learn this one by one. So, based on the geographical location, it can be classified as a continental basin that form within the land masses. It also classified as coastal basins which are located near the coastlines and which are affected by marine and riverine processes. Then there is marine basin which is found beneath the oceans and the seas. Then the inland basins which are located within the continents far from the oceans. So, these are some classes based on geographical locations. Now, looking at the classification based on the sedimentary fill and depositional environment, it is the type and thickness of sediments deposited in the basin that on the basis of which the classification is done. So, one class is clastic dominated basins, which is filled with sediments like sandstone, shale and conglomerates, like for example, in the Indo-Gangetic basin. Then the second type is the carbonate dominated basins, which contain mainly limestone and dolomite, which often associated with coral reefs like in Arabian basin. Then evaporite basins, which contain salt, gypsum and other evaporite minerals due to high evaporation rates like in Rajasthan basin. Then the fourth class is mixed depositional basin, which contain both clastic and carbonate deposits, for example, in Cambay basin. Then based on the tectonic setting, we can classify them into cratonic basin, which is also known as the intra-cratonic basins, which are located in the stable continental interiors and formed due to long term subsidence in the lithosphere, for example, Katappa basin and the Vindhyan basin. Then the second class is the rift basin, which is formed by extensional tectonics, where the earth's crust stretches and thins and these are associated with the faults and the volcanic activity for Narmada Rift Basin. Then the foreland basin, which has formed adjacent to the mountain ranges due to the collision of tectonic plates and accumulate large amounts of sediment from eroding mountains like Indo-Gangetic Basin. The fourth type is the passive margin basins, which are located along continental margins where there is no active tectonic activity, and they are associated with major petroleum reserves, for example, Krishna Godavari Basin. The fifth class is the pull apart basins, which are formed due to strike slip faulting that refers to the horizontal movement of tectonic plates, like for example, Narmada Tapti Basin. Then the sixth class is the trench and back arc basins, which are formed along subduction zones where one tectonic plate sinks beneath another, like in Andaman Basin. Then based on the hydrocarbon potential also we can classify sedimentary basins into certain classes. Generally based on their hydrocarbon prospectivity, the sedimentary basins are classified into four types. The type 1 is the category 1, that is proven reserves and commercial production basins with established oil and gas fields. Then second category is the category 2, which is significant discoveries and limited production. So, the basins with hydrocarbon potential, but limited commercial production falls under the category 2. The category 3 is the prospective no commercial production, and these are the basins with indications of hydrocarbons, but no commercial success yet. Then the fourth is the category 4, the least explored basins. The basins with minimal exploration data fall under this category, like Himalayan Basin and the Deccan Synclinal. Based on subsidence mechanism also it can be classified, like the first class is the thermal subsidence basins, which are formed due to the cooling and contraction of the lithosphere. Then the flexural subsidence basins, which are formed due to the bending of the lithosphere under tectonic forces. Then the strike slip subsidence basins formed along strike slip faults due to lateral movement. So, we have talked about the various types of sedimentary basins and on the basis and various factors on the basis of which they are classified into different types. So, we have seen that sedimentary basins are classified based on the multiple criteria, including the geographical location, depositional environment, tectonic setting, hydrocarbon potential and subsidence mechanism. So, this classification helps us in better understanding their formation, evolution and economic importance, especially for oil and gas exploration, also for groundwater studies and geological research. Now, let us learn about the characteristics of sedimentary basins. So, whatever classification that we have seen, that again we can look into in a different perspective. So, those bases on which they are classified, they could also become the characteristics of sedimentary basins. So, the first characteristics could be the structural characteristics, like the tectonic origin, which like how they have formed, whether due to the subsidence by rifting or the crustal fracture or thermal contraction. Then basin shape is another characteristics. It can be elongated, circular, asymmetric or fault control. Size and depth could also be different characteristics in terms of their structures. So, that it might range from small local depressions to vast continental scale basins. Then the subsidence mechanism controlled by tectonic movements, lithospheric flexure or sediment loading. The second characteristics could be the stratigraphic characteristics, and under which the we can again look into various other parameters, like the layered sediments, whether it contains well defined stratigraphic layers with younger rocks deposited over the older rocks. It might contain unconformities, which is gaps in sedimentation due to erosion or tectonic uplift. Then the depositional environments that include fluvial, deltaic, lacustrine, marine and aeolian settings, and also the facies variation. So, lateral changes in sediment composition, texture and the fossil content. they could be useful for characterizing a sedimentary basin. Now, let us look into the various kind of depositional environments. We have read in that course BGYCT 135 Petrology that there are basically two types of environment, continental and the marine. So, under the continental we have the fluviatile, that is the main agent is the river, and in the aeolian environment it is the wind, that is the major agent for transportation deposition. Lacustrine, it is the lake currents and waves, and glacier environment it is the ice or the glacier. Then in the marine environment it is the shallow and marginal marine, it could be coastal and transitional. So, where it could form at the continental shelf, beach, delta or tidal flat or the barrier reef and estuaries. Then there could be deep marine, that is open ocean, and the continental slope, offshore and the deep ocean. Now, this block diagram shows this various environment. You can see alluvial in the top in the left, then the glacier, then evaporites, lacustrine, then you have aeolian, then lagunal, then in the beach, deltaic, tidal, shallow water, and then deep water marine at the right side. So, these environments are built around rivers, deserts, lakes, glaciers and the sea oceans. So, fluviatile environment occurs in the river channel and the floodplains. We know that the rivers provide widespread alluvial deposits on the continents. For example, the Indo-Gangetic alluvial deposits. Now, coming to the aeolian environment, that represents an arid type of climate, and since the aridity inhibits organic growth, therefore, the organic impact in that environment is little on the sediment. So, desert sand dunes, for example, the Thar deposits provide a sandy environment. Coming to the lacustrine environment, it encompasses inland bodies of fresh or saline water which are controlled by the relatively small waves and moderate currents. Saline lakes in the desert evaporate and precipitate a variety of minerals such as halite, for example, in the Sambhal lake deposits. Then coming to the glacier environment, it is controlled by the dynamics of moving masses of ice and is characteristics of a cold climate. And the marine environment include a variety of sub environments ranging from shallow water to deep water, like for Bengal fan in the Bay of Bengal and the beaches at various places across India. Now, coming to the third characteristics, that is sedimentological characteristics. Sediment source could be another characteristics that could be helpful in characterizing a sedimentary basin. So, whether the sediments are derived from erosion of surrounding highlands or volcanic activity or the biogenic processes, then the thickness and the composition, it could vary from a few meters to several kilometers of sedimentary fill, including sandstone, shells, limestones and the evaporites. Then the clastic versus the carbonate dominance, what is dominant there in that basin. Some basins may be dominated by the clastic deposits and some others may have carbonate rich sequences. There could be presence of fossils also in some of the sediments, often contain the paleontological records helping in age dating and paleo-environmental reconstructions. The fourth is the geophysical characteristics like gravity and magnetic anomalies that could reflect variations in the crustal thickness and the subsurface rock types. The seismic reflection patterns that is used to study the basin field, fault structures and hydrocarbon traps. Crustal thickness could be another parameter. It could vary with deep basins often having thinner crust due to stretching. Then the thermal maturity, the temperature and burial history determine hydrocarbon potential. Coming to the fifth, that is hydrocarbon and mineral potential. The petroleum systems, like many basins, are rich in oil and gas due to organic rich source rocks and suitable trapping mechanism. Then the coal deposits, which are found in continental and deltaic basins with high plant accumulation, and there are some which have metallic and non-metallic minerals. Then the groundwater reservoirs. So, this is important resource of freshwater storage in porous sedimentary rocks. So, if you can summarize what we have seen in the characteristics of sedimentary basins. Sedimentary basins are the dynamic geological systems that record Earth's history, host important natural resources and are influenced by tectonic, climatic and sedimentary processes. Their structural, stratigraphic and geophysical characteristics determine their economic and scientific significance. Now, let us learn about the sedimentary basins of India. India has 26 sedimentary basins that cover an area of about 3.14 million square kilometers, and as we have learned earlier, they are classified into 4 categories based on their hydrocarbon prospectivity. So, under the category 1, it is the proven reserves and commercial production, and these basins have well established oil and gas fields. In category 2, which are significant discoveries and limited production. These basins have hydrocarbon potential, but are not commercially developed. In the category 3, these basins have indications of hydrocarbon presence, but no confirmed production. Category 4 are the least explored basins, which have little or no exploration data. Now, coming to the various sedimentary basins of India, if you can name them, it is the Mumbai offshore basin that is located in the western India, and it is characterized by thick tertiary and Mesozoic sediments located on a passive margin, and which is one of the most productive oil and gas basin of India. Krishna Godavari basin is again significant because of its major hydrocarbon production onshore and offshore, and it is located in the eastern coast of India. Kaveri basin is located in Tamil Nadu, southern India, Bay of Bengal, and its characteristic is the rift basin and has Jurassic to Cretaceous sediment layers, and it is a significant hydrocarbon exploration area. Cambay basin is in Gujarat, northwestern part of India, and it has tertiary and quaternary sedimentary sequences, and it is the early oil producing regions in India. Then Rajasthan basin, located in Rajasthan, western India, it is part of the Indus basin, has tertiary and Mesozoic sediments, and has recent oil discoveries. Then Assam Arakan basin, which is located in the northeastern India, it is basically foldland basin with tertiary sediments, and it is one of the oldest oil producing regions in India. Then the Ganga basin, which has a key resource of groundwater and coal. It is located in the northern India, Uttar Pradesh, Bihar, West Bengal. It is characterized by thick alluvial sediments, tertiary sequences. And Mahanadi basin, which is in the eastern India, in Odisha, Chhattisgarh, Bay of Bengal, has a Mesozoic and tertiary sediments and is significant for onshore and offshore hydrocarbon potential. Vindhyan basin, it is in the central India and has characterized by Proterozoic sedimentary rocks. It is significant for minerals and not major for hydrocarbons. Godavari basin in Maharashtra, Telangana, Andhra Pradesh, and it is the key coal mining region. Satpura basin is important for again coal mining, coal resources. It again is in central India. Damodar Valley basin is in eastern India, which is a major source of coal for thermal power plants. Is characterized by Gondwana coal bearing basin. Saurashtra basin is in Gujarat. It is offshore basin with hydrocarbon potential, and Bengal basin in eastern India, characterized by deltaic basin formed by Ganges Brahmaputra sediments. It has potential for natural gas and significant for groundwater. So, we have seen the various major sedimentary basins of India. If you can categorize them further into based on what is the resource in it, so we can call them as a hydrocarbon basin. These are like the Mumbai offshore basin, Krishna Godavari basin, Kaveri basin, Cambay basin, then Assam Arakan basin are the most productive for oil and natural gas exploration and production. Then the coal rich basins like we saw the Damodar Valley Basin, Godavari, Satpura, etc. They are the most important coal bearing basins in India. Then the groundwater basins, the Ganga Basin and the Bengal Basin are the significant for their extensive groundwater resources. Then minerals rich basins like in Vindhyan Basin, which is notable for its limestone, dolomite and phosphorite deposits, although not for hydrocarbons. Now, let us discuss the importance of sedimentary basins. We can understand its importance based on various parameters. Let us first see the economic point of view. It has the hydrocarbon resources, the oil and gas exploration in the basins like Mumbai offshore, Krishna Godavari basin and the Cambay basin, and coal deposits which are found in basins like Damodar Valley and Son Valley, the groundwater resources, and these are all vital for the discovery and extraction of oil, gas, coal and minerals. From the scientific point of view, it is useful for paleoclimatic studies like the fossils in sedimentary basins that help us reconstruct the past climate. It also helps us in understanding the tectonic evolution, and it provides insight into the earth's past climate, environments and tectonic movements. Coming to the environmental and ecological point of view, many basins host rich ecosystems and so they, like for example, Sundarbans in West Bengal, in Bengal basin. So, they are important, and these are also key for disaster risk reduction, climate change studies and habitat conservation, and even for natural disaster management. It is useful as understanding the sedimentation patterns helps in the flood control. It is also useful for infrastructure development, like it influences the engineering projects and urban planning. Then it is also essential for managing natural resources in a responsible and environmentally sound manner. So, the sedimentary basins are fundamental to economic growth, in energy security and scientific research. Understanding their formation, classification and resources is crucial for sustainable exploration and management. With advancements in technology and policy reforms, India's sedimentary basins hold significant potential for future energy and resource development. So, now we have learned about the importance. However, there are some challenges in their exploration, like in deep sea explorations there are specific challenges. Then for offshore drilling there are technological and financial constraints, and in the Himalayan basins it is a difficult terrain, and there are also environmental concerns and land acquisition issues in some of the areas. However, if we talk about the future prospects, the enhanced oil recovery techniques could be used to improve hydrocarbon extraction, and the unconventional energy exploration like shale gas, coal bed methane, it also holds potential, and there are government initiatives that is helping to encourage private investment. So, in this session we have learned about the basin, we have learned the definition of basin from different contexts, then the various types of sedimentary basins that we have seen based on various parameters. Then we have seen about the characteristics of sedimentary basins. Then the major sedimentary basins of India, we get an overview of those. Then towards the end we saw how is the sedimentary basins important and what are the challenges in studying them or in the exploration, and we also saw what is the future prospects of this. Thank you.